Assalamu alaikum wa rahmatullahi wa barakatuh. Karibuni tena. Welcome once again to Mewa Hub, Mewa Digital Hub channel. Just like usual, we're going to study something new. So today I'm focused on teaching you, if I'm not wrong, I'm focused on teaching you this paper. Just passing you through this paper, KCSE. Okay, KCSE. So this is KCSE Chemistry, Paper 1. KCSE Chemistry, Paper 1 2024. Okay, so basically just telling you how it looked like, and also I'll be answering some few questions. Okay, so if you look at it, Paper 1 is mostly theoretical. So it's mostly of theory, especially Paper 2 is mostly theory. But now Paper 1 just asks you the basic knowledge, so it's more of knowledge questions. But for the Paper 2, it asks you application questions. So basically, it wants to test if you can apply this chemistry into your daily lives, how you apply it, and etc. So, but for Paper 1, it's just theoretical. It just looks at whether you know what a concept is or looks like, or just more of a knowledge question. So if you look at this Paper 1, most of the students think that Paper 1 is mostly Form 1 and Form 2, but it's very wrong. Somehow true, but not entirely true. You might find other questions from Form 3 or Form 4. Not all Form 1 and Form 2 are tested in Paper 1. Sometimes you might find some topics or Form 1 are tested in Paper 2, especially the practical questions. For now, let's delve into the paper and let's look at what they tested, or what did they test in the previous year. So for the first question they tested, they were looking mostly on the introduction part. So they're introducing chemistry to the learners. So introduction to chemistry, especially on the apparatus side. Okay, so what are the different apparatuses, what are the uses, and etc. So if you look at, sometimes you might get luminous or non-luminous flame type of question. So probably just be ready to receive such type of questions. But question 2 mostly was focusing on radioactivity. Okay. For the third question, it was focusing on salts. So mostly it was on salts. Fourth question, enthalpy changes. The Form 4. So just like enthalpy changes, especially the exothermic and the endothermic reaction. For question 5, nitrogen and its compound, because of ammonia. Nitrogen and its compounds. So when you look at the paper, you realize that some questions are in Form 3s or Form 4s. Now we also have reactivities, especially reactivity series. It basically looks at Form 2. So reactivity series is most of the times I think it's on air and combustion, or on water and hydrogen. Okay, but mostly I think it's on it's on this air and combustion. And then we have moles. Okay, moles, where you use the mole ratio, the RMM, the empirical formula. So that's one. When you go to question 8, is on organic chemistry 2. That is So I think this questions continue. If I'm not goes, so this can still continue. So no, there's another question, question 8 on organic chemistry 2. That should be sure just organic chemistry. So you should have the basic knowledge of organic chemistry 1 and 2. Then we have this one, hydrocarbons. So water and hydrogen. Then we have this one, heat change, still molarity, moles, but now it's more of moles and temperature changes. Okay. Iron is extracted from its ore in a blast furnace, mostly on methods. Okay. Because it teaches more on extracting metals. So the topic of metals is dealt. Yeah. You can also have bonds, bondings, chemical bonds. Also have acidified potassium dioxide. This is just the same question. Again, enthalpy changes. So again, enthalpy changes. We also have electrolysis. We have electrolysis. We have also again organic chemistry 2. And classification of substances from 1. Chromatography. Then again moles. If you see, you should have the basic moles, and this is look at moles. Yeah, it looks at moles, and also you should know air combustion. Okay, because it looks at the preparation of oxygen as well. So some questions are combined, but most of the questions you should have the basic information about moles. Again, sample of ammonium nitrate can be prepared starting with ammonia, as the only nitrogen containing steel salts. Then we have this one, carbon and its compounds, preparation of carbon oxide. So carbon and its compounds. So yeah, we also have again the mass of water, again moles, activation energy, still enthalpy changes. Okay, this one can say the basic information for, I think it's about atoms, atomic structure. So because just like from the table, so this one deals with Form 2, first topic, that is atom structures, atomic structures. For this one again, oxidizing and reducing agents, still atoms. For this one, if we look at it, most probably is salts, and also can be metals, but salts I think, because seeing that there's a question on ionic equation here. This one, sustaining a fire required strict ingredients, still carbon, about fuels, helium, moles, not moles, but I think the second topic, gas laws, guys. Okay, but you can be sure, but we look at it. So those are the questions that you'll encounter. So for the first question, it's asking you about the apparatuses that you know, or the uses of those apparatuses, which type of apparatus belongs to or has a certain use. So for the first question, name the apparatus that can be used to measure volumes of solutions more accurately than a measuring cylinder. So obviously here, the apparatus that can be used, it includes burette. Okay, you can also use pipette to give you slightly accurate volumes, or you can use a volumetric flask, and etc. Okay, as long as the apparatus that you stated, they measure, they give an accurate measurement, not approximate. The second one, low a burning piece of magnesium ribbon into a gas jar, that is a deflagrating spoon. Okay, there are also some apparatus that has the same function. They can include pair of tongs. You can use a pair of tongs. Okay, you can use a test tube holder, maybe it's for improvising, but metallic test tube holder. Okay, you can use a pair of forceps, but the main answer was deflagrating spoon. Pair of forceps, not tongs. Store and keep substances free from moisture. This is just one answer. That is a desiccator. So what a desiccator does, it just keeps substances free from moisture. So whatever substance you're storing in it is usually free from moisture. Doesn't get altered by the moisture. Now, question 2: a radioactive isotope decays by either emission of alpha or beta particles. So question A: explain why alpha particles have a higher ionizing power compared to beta particles. Now, this is a topic on radioactivity, so if you haven't reached, it's best to go and study it. But now, the difference between alpha and beta particles is just the size. Okay, one is usually bigger and the other one is smaller. So the alpha is usually bigger than the beta. So the alpha so you can let's take an example. Sometimes you have a ball, and then that ball, you might blow it or get destroyed, so it might explode. So once that explosion happens, it usually emits bigger particles, so those are called the alpha particles. The smaller particles are now what we call the beta particles, the electrons and etc. So the difference between it is the size and the speed in which it flies away. So the alpha particles usually are big, but they're very slow. The beta particles are very small, but they're fast enough. Okay, so question A: explain why alpha particles have a higher ionizing power compared to beta particles. Is the reason is very simple. Since alpha have bigger particles compared to the beta particles, so the alpha particles take time to move. So that's time to move. It means that it also is given time for it to be in contact with other substances, and that contact usually allows it to react with other substances. As for the beta, since they are fast, the reaction time is very slow. Therefore, they tend to have a lower ionizing power, and also due to their size as well, they have a higher charge. Okay, the alpha particles have a higher charge, so they have the ability to pull electrons. So those are two reasons. Whichever reason that you might write is still correct. So the first reason is that the alpha particles they have a higher charge, therefore they pull, so they have the ability, high ability to pull electrons or to attract electrons. That's why distribute electrons. So that's the first reason. Okay, the other reason that I can give maybe is that the alpha particles have higher mass, or the big in size, so they have high mass, leading to slow speed and more contact. And more contact time with substances. So more contact time with substances. Hopefully that answers our question. So if it gives more contact time with substances, therefore it has the ability to attract to build the electrons. So for question B, explain why alpha and beta particle can be distinguished in terms of their penetrating power. Since the alpha are usually bigger, so they tend to not pass through paper. Okay, they're bigger in size, so they can't pass through anything very easily. But for the beta particle, since they're smaller, so they have the ability to penetrate into many substances, especially paper, but not aluminium foil. Okay, or not aluminium foil. So you can answer it like this. You can say that alpha particles. So you can, the first answer that I can give out, alpha particles have low penetrating power. And are stored by paper. So that's just 1 mark. Or you can say that beta particles, okay, or while beta particles, they need to, but still it's the same. While beta particles have high penetrating power. Let me just write this. And not easily stored by paper. Just they pass through paper. And pass through paper easily, but not aluminum foil. Pass through paper. Okay, but are stored by aluminum foil. So someone wants to ask you, a beta and alpha particle, just particles that come from an atom. So it shouldn't confuse you of some such. So question 3, salt. 3 bottles containing zinc nitrate, aluminum nitrate, or lead 2 nitrate have their labels missing. Describe a chemical test that can be carried out using aqueous sodium sulfate and aqueous ammonia to label the bottles correctly. Okay, so a chemical test that can be carried out using aqueous sodium sulfate and aqueous ammonia, okay, to label the bottles correctly. Okay, so now so this is 3 marks, so you should be somehow systematic in your answering. Okay, so for the first procedure, you just take a sample of the nitrate, react it with sodium sulfate. So if a white precipitate is formed, then the salt is lead 2 nitrate. Okay, so if you haven't watched the topic on salts, you can go to the channel, go to the video where I taught salts. So 3 bottles, zinc nitrate, aluminum nitrate, or lead 2 nitrates have their labels missing. So describe a chemical test that can be carried out using aqueous sodium sulfate and aqueous ammonia to label the bottles correctly. Okay, to label the bottles correctly. So first, react a sample of the nitrate, or a sample of the nitrate react a sample of the nitrate. You might not know which one is it, but react a sample of the nitrate. Can be zinc nitrate, aluminum nitrate, or whichever, with sodium sulfate. Okay, so if a white precipitate is formed, then it basically led to nitrate. Okay, so if a white precipitate, or if a white PPT is formed, I'm just writing, but you shouldn't write it like this in the exam. If a white PPT is formed, the salt is lead nitrate. So we label that salt as lead nitrate. Salt is lead to nitrate. Okay, just take a sample of each nitrate. It's lead to nitrate. Okay, why is it lead to nitrate? It's because when you take lead to nitrate reacted with sodium sulfate, there's a reaction that will happen called double decomposition or precipitation reaction. So therefore the sulfate will be taken in by the lead, or the lead will replace the sodium. As a result, you'll find lead sulfate being formed, and lead sulfate is usually insoluble in water, therefore a precipitate will be formed. But for the others, like let's take an example for aluminum nitrate, zinc nitrate, they may form zinc sulfate or aluminum sulfate, but they're still soluble in water. Remember, all sulfates are soluble apart from barium sulfate, calcium sulfate, which is slightly soluble, and lead sulfate. Okay, so we've used the aqueous sodium sulfate well. And then you also take again react a sample of the nitrate with which compound again? With aqueous ammonia. With aqueous ammonia. So in my form, it forms a precipitate. It forms a precipitate. If it forms a precipitate that dissolves in excess, it forms a precipitate or PPT that dissolves in excess, then the salt is zinc nitrate. The salt is zinc nitrate. Let me just write it like this: zinc nitrate. Why? Okay, so zinc ion usually forms a complex ion with excess ammonia. So if you take zinc reacted to the ammonia, zinc nitrate reacted to the ammonia, it gives you zinc hydroxide, which is a precipitate, because most of the hydroxide are usually insoluble in water. So it forms a precipitate at the beginning stage, but later if you add excess ammonia into zinc nitrate, the zinc ion will react to the hydroxide to give you a complex ion called tetraamine zinc. Okay, tetraamine zinc, which is a soluble ion. So if it dissolves in excess, then just know that that is zinc nitrate. So we just be remaining with aluminum nitrate. Okay. Now react a sample of the nitrate again. React a sample of the nitrate. We have space now. React a sample of the nitrate with aqueous ammonia. With aqueous ammonia, if a precipitate is formed, but if the precipitate just persists to be a precipitate, and persists even after adding excess ammonia, then that salt is aluminum nitrate. And persists after adding excess ammonia, then the salt is aluminum hydroxide. Okay. Otherwise, if it's dissolved, then it is zinc nitrate. the salt is aluminum nitrate. So so the sodium sulfate, if I'm correct, is basically used to test for lead to nitrate. The ammonia is used to test for zinc nitrate and aluminum nitrate. So when you react ammonia into zinc nitrate, it forms a white precipitate at the beginning stage, but later dissolves to form tetraamine zinc. But the aluminum nitrate just persists to be insoluble in water because there won't be any complex ion formed from it. Okay, so the only two usually that form complex ions, zinc and lead, only those two. You don't have aluminum, tetraamine aluminum there. Let's go to question 4. Consider the following equilibrium reaction for a mixture of gases in a gas syringe. You have nitrogen dioxide. You also have nitrogen dioxide, but one is brown and the other one is yellow. The enthalpy change is negative, just like you see from the diagram. Now the question asks, give a reason why the enthalpy change is negative. Okay, so if your enthalpy change is negative, then it means it's an exothermic reaction. Okay. And question B asks you to state and explain the observations made when the pressure in the syringe is increased. So the observation and the explanation are required for this question. Now, the reason why enthalpy change is negative is because there will be formation of bonds. So the reaction itself involves a bond formation. Okay, the reaction involves bond formation. And how do you know if bonds are formed? So if it involves bond formation, it's usually exothermic. So bond formation, especially when you're creating bonds, it requires heat energy to create those bonds. So therefore, you absorb heat. Do you really absorb heat, or do you no? Bond formation doesn't require energy. If you're breaking bonds, you require energy. That's why you absorb heat energy. Therefore, the reaction is known as endothermic reaction. But for reactions that involve in bond formation, it requires less heat energy, and therefore the heat energy that is stored within escapes or is eliminated, and therefore is an exothermic reaction. So for this case, it involves bond formation. How do you know it involves bond formation? Because you had nitrogen dioxide. Now we have this one. It's also nitrogen dioxide. If you know the name for this compound, you can say it on the comment box. It's not called nitrogen dioxide. It's similar. It's just nitrogen dioxide. But now there are new bonds formed. Just like from the diagram that you see here, we had one nitrogen, but now we have two nitrogens. So an additional nitrogen was added, and also additional oxygen atoms were added. So therefore, we had bond formation there. Question B, state and explain the observations made when the pressure in the syringe is increased. Okay, when the pressure in the syringe is increased. So if the pressure is increased, what will happen? Okay, what will happen? So the yellow color intensifies. The yellow color will intensify, which is that one. So the yellow color intensifies, or you can say it becomes more yellow. Okay, or you can say the brown color changes to yellow, whichever. But the yellow color intensifies, and the explanation to it is because the equilibrium shifts to the right. Equilibrium shifts to the right, because when there's a pressure, it means that the bonds come together. Therefore, the equilibrium shifts to the right. Okay, shifts to the right. The direction with few molecules. Or you can say forward reaction is favored, etc. Blah blah blah. Okay, so when there's pressure, usually the equilibrium will shift to the right where there's low molecules. Okay, low molecules are seen, they're not far from each other, they come together. For fifth question, okay, for the fifth question is this one. Ammonia gas can be prepared using ammonium sulfate and sodium hydroxide. Write any reaction and equation for the reaction. So this also salts, and also it can be nitrogen and its compounds. So we have ammonium sulfate. Ammonium sulfate is written like this. Okay, if you were to write the formula, remember that the ammonia is written like this. It's ammonia. So ammonia is written like this. The sulfate is written like this. So when it's an ion, it's written like this. So the ammonia will take the 2 from the sulfate, and the sulfate will take the plus from ammonia. So as a result, it becomes ammonium, which will take the valence of 2, and the sulfate will take the valency of 1, which will just remain the same. So ammonium is a radical, and radical are groups of atoms that react during a chemical reaction. They react as one unit. So, okay, and they have a net charge in it. So this is ammonium sulfate reacting with sodium hydroxide. Sodium has a valence of 1, hydroxide also has a valence of 1, so therefore becomes sodium hydroxide. So ammonium sulfate here is a solid. Ammonium sulfate is a solid. Depends, no, it's not a solid, it's an aqueous, because it dissolves in sodium hydroxide. So it's in aqueous state. So sodium hydroxide is also in aqueous state. So this is a double decomposition. The sodium will take the sulfate, and the ammonium will take the hydroxide. So at the end of the day, this is ammonium hydroxide, but ammonium hydroxide is somehow stable, so it dissociates itself to give you ammonia and water. With the sodium, it will take sulfate, therefore becoming sodium sulfate. Sodium sulfate, sodium has a valence of 1, will be taken by sulfate. Sulfate has a valence of 2, the 2 is taken by sodium. Therefore, you have sodium sulfate, okay, which is aqueous as well. And then we have ammonia and water. This is the ammonium hydroxide now, which is a gas, not an aqueous, then water. Now let's balance them. Let's balance them. So if you look at here, we have 2 ammoniums, by the way. So we have 2 ammoniums on the left side. We have only 1 ammonia on the right side. So you can write like 2 here. Okay, so you have 2 ammoniums. And the hydrogen, we have how many hydrogen? 8 hydrogens, 9 hydrogens to say. But on the right side now we have 8. 6 plus 2, 8. On the left side you have 8. Okay, it means that we need to put 2 here to give you 10. So we have 10 hydrogens on the left side. We also need to have 10 hydrogen on the right hand side. So let's just put 2 here. So, and I think there it's balanced. Okay, it's balanced. This is balanced. Okay. Let's continue then. Draw a label diagram of a setup of the apparatus that can be used to prepare and collect a sample of dry ammonia. Okay, I'm not a good drawer, so you just bear with me. So this is the flask. Then you're connecting the flask to something for drying. But inside the flask we have those ones, sodium sulfate and the ammonia. So you have sodium hydroxide, by the way. You have ammonium sulfate. Let me just write it in chemical formulas. So we have ammonium sulfate and sodium hydroxide. And then remember we have heat. Okay, your heat should be here. If you want, you can just say this is your heat. You're heating it. Now it's connected to a drying agent. Which is this. Let me just draw it casually. I'm not a good drawer, but during exams I make sure your drawing somehow accurate. Now, so this is the U tube. So it has, well, what does it have? Basically, it has the drying agent, which is calcium oxide. Okay, just fill in everything here. So this is the calcium oxide. So what does it do? It dries. So because ammonia has water inside it, you need to dry the ammonia to give you dry ammonia itself. And then we collect the ammonia using upward delivery because ammonia is less denser than air. So you collect it using the upward delivery method, and this is your ammonia. Okay, so this is ammonia gas now. So 2 marks. Sabure. Now let's go to the other question. Okay, question 6. Some properties of 4 metals and their oxides are shown in table below. Which is metal A reacts slowly with steam. Color of oxide is usually green. So metal B reacts rapidly with steam. I think this is hydrogen, water and hydrogen. Metal C reacts rapidly with cold water, giving a white oxide, and D doesn't react, giving a black. Okay, so one reacts slowly, and the other one reacts rapidly, and the other one reacts rapidly with cold water, and the other one does not react. So basically, we need to know which one is more reactive than the other. So arrange the methods in order of their reactivity, starting with the most reactive, then followed by the least reactive. So the most reactive is the one that reacts rapidly with cold water. Okay, because if it reacts rapidly with cold water, basically it means that it can react rapidly with steam as well. So if it reacts less slowly with cold water, it might react rapidly with steam. So this shows that B reacts slowly with cold water. Okay, so that's why we are starting with the C. So the C is the first one, then followed by B. Okay, then followed by A. Well, basically the one reacting rapidly with steam is more reactive than the one reacting slowly with steam, and then followed by the one that doesn't react. Therefore, it can't displace that element in that compound. So CBAD. So you write it. This is in terms of decreasing reactivity, because we started with the most reactive. So this is decreasing reactivity. But BB, this question has become specific. So if you write like this, you can be accepted. But if you just draw an arrow which says increasing reactivity, okay. But now the question is specific. You've been told to start with the most reactive. Then why writing starting with the least reactive? Question B, state the observation that will be made when metal B is heated with oxide of D. So when metal B is heated with oxide of D, okay, basically metal, I just look at it. So you have metal B heated with oxide D. I don't know which type of oxide. Let me just write it DO. So since B is more reactive than D, you'll have BO, okay, plus D. Maybe it's a gas or some sort, I'm not sure. So and BO, so since it displaced the D from its compound, E imekuja kwa D ikamtoa, so it became an oxide. Therefore the color change that you'll see there is because let's look at B, is brown. So it will change from DO, which is black in color. Okay, so it changes from black to brown. So color change. Okay, let me just, so color change from black to brown. Change from black to brown. The oxide of C, so now you're taking B reacting with the oxide of C. So most probably look at which one is reactive. So C being reactive, then B, no reaction will take place. So it just persists. So the color of CO, which is oxide of C, is white. So the white color persists. So no color change. So no color change, or the solid remains to be white. Why did we say there's no reaction? Because B can't displace C, because C is more reactive than B. So the solid remains to be white. So for question 7, we have question 7. An experiment to determine the water crystallization in sodium carbonate, which is sodium carbonate dot XH2O. The data in table 2 was obtained. So which is mass of crucible plus salt before heating. We have mass of crucible plus salt after heating. So calculate the mass of dry salt after heating. Okay, let's calculate the mass of dry salt after heating, and this might be our last question. So when we get time, I think I will do the other questions, inshallah. So because I'm told the video should be not more. Okay, it should not be not more than 40 minutes. Especially, also I agree on that. I don't want to be a long video and then you don't capture anything from the video. Okay, so calculate the mass of dry salt after heating. Let's calculate the mass of dry salt after heating. So, but first we need to subtract things here. So the mass of crucible. So let's remove the mass of crucible. That is, how do you remove the mass of crucible? Let's take 67. Okay, that is, but let's take the salt, the mass of salt after heating, or salt after heating. The mass of salt after heating will be 67 minus 57. So 67.00 minus 57.20. And let's look at how much it gives us. So 67 minus 57.2. So this one gives us 9.8 together with the water that is there. Now the mass of salt before heating. Which will be 78.60 minus 57.20 minus 57.2, which is 21.4. Okay, 21.4 grams. But 21.4 grams. But the question was, just to calculate the mass of dry salt after heating. The mass of dry salt after heating. The mass of dry salt after heating, I think it's just 9.8 grams. So it's this one. The mass of dry salt after heating is just 9.8 grams. Mass of water, that is, now when we take 21.4 grams, you subtract it with 9.8 minus 9.8 gives you 11.6. So let's take the mass of salt before heating minus the mass of salt after heating, which is 21.4 grams minus the 9.8 grams, and it gives you the mass of water, which is 11.6 grams. Okay, 11.6 grams. So hopefully I think we're together. Now let's now find the value of X. So here we will draw something. Sodium carbonate, we have water of crystallization, and then we draw a table. And the table is not that big. So in the table we need to have mass, or the RFM. Let's start with the mass. Let's start with the mass. The mass of sodium carbonate was 9.8 grams. The water was 11.6. Okay. The RFM for sodium carbonate would be how much? So sodium carbonate, remember sodium is 23. So 23 times 2, 10 plus 16, if I'm correct, okay. It's 12. 12 plus 16 times 3. Oxygen is 16. So it gives you how much? 3 times 2 plus 12 plus 16 times 3. It gives you 106. So the RFM for sodium is 106. Okay. The RFM for water, hydrogen is 1. And since you have 2 hydrogens, you write it as 2 plus 16 for oxygen. So it gives you 18. And then now we're calculating moles. And how do you get moles? Is mass over RFM. So you're taking 9.8 divided by 106, which gives you 0.09 moles. And 11.6 divided by 18 gives you 0.64. Now, mole ratio. The mole ratio is easy. So for you to calculate the mole ratio, you divide by the lowest moles, which is 0.09, divided by 0.09. This one gives you 1. This one will give you how much? It will give you around 7. So if you round it off, it should be 7. So the mole ratio will be 1:7. So therefore the compound will be written as sodium carbonate, but with 7 water of crystallization. So dot 7. So the value of X is 7. Okay, value of X is 7. Yeah. So with that all, let's stop there. But hopefully you've understood most of the questions here. So with that all, let's stop there. And inshallah in the following week maybe we might be looking at another topic with questions, because since KCSE is approaching, I'll be looking at questions of a certain topic. So I'll be revising through those questions. So don't forget again to subscribe to Mewa, just like usual. Yes, yeah. So also don't forget to reach out through me. I also have my YouTube channel for Max, known as Mind Mastery Tutor. So whenever you have the time, you can also go and follow that page as well. Shout out to Mewa again. Don't forget to subscribe to them. And I'd say assalamu alaikum wa rahmatullahi wa barakatuh.